Okay, so symmetry of functions, even odd functions. And we already saw a little hint of this earlier today. So even function is a function that is symmetric with respect to the y-axis. So these are functions that look like a mirror. The y-axis is like a mirror. In other words, let me go back to our picture. You realize that this is symmetric because if you were to fold this picture along the y-axis, remember this is the y-axis, if I were to fold this, then the two pieces of the graph they will overlap with each other. Okay, that's what it means to be symmetric. If I fold this picture, like mine, this is a paper, if I fold it, this part will overlap with this. Do you understand what I'm saying? So the defining property is what? That every time, and this is the formality, every time that you have a point on this side, it has a partner on the other side. Okay? And what's the partner? You keep the same y, just reflect it over, just change the sign of the x. So if 2, 3 is on the graph, then negative 2, 3 has to be on the graph. Okay? If 4, 9 is on the graph, then negative 4, 9 has to be on the graph as well. Okay? So what's the definition? If x, y is on the graph, then negative x, y is also on the graph. Okay? Whenever that happens, we give it a name. It's called an even function. So let me write that down. So this is the notion of, so for symmetry, first let's talk about even functions. And I guess yeah, okay. Doesn't matter. Let's just go straight with the definition. So basically, suppose that you have the following condition. So if x, y is on the graph, then I want a function to be even means that it's symmetric with respect to the y-axis. Okay, it's symmetric with respect to the y-axis. So that means every time that we have something going on this side, on the right side, it has to reflect over to the left side. So if x, y is a point on the graph, then negative x, y has to be also a point on the graph. So the condition is if x, y is a point on the graph of f, then negative x, y is also on the graph of the function f. Okay, so that's what it means to be an even function. That's the definition. So now let's try to, to be able to identify this a little bit more algebraically. So basically, what we're saying here is that the y value of both x and negative x is the same, right? Do you understand this? Remember, this second number here is the y value corresponding to the first number. So we are saying that the y value of both x and negative x is the same. In other words, another way of talking about the y value of x is f of x. Another way of talking about the y value of negative x is f of negative x. And then we're saying that these two things have to match. Okay? So this is what it means to be even. So a function is said to be even if when you plug in negative x, you get the same thing as if you had plugged in just x. In other words, both x and negative x, they always have the same y value. In other words, it doesn't matter whether you plug in positive or negative. You will always get the same one. Okay? So this is how you can algebraically determine that a function is even, and geometrically it means symmetry with respect to the y-axis. Y-axis is a mirror. Do you understand this? Let's see, who can tell me what's a classical example of an even function? What's the first thing that comes to mind? X squared, right? So the classical example here is x squared. Because it doesn't matter whether you plug in x or negative x, you will get the same thing. So know that if you do f of negative x, what is this? That's negative x squared, which is just x squared, and that's just f of x. So f of negative x equals f of x, and as you probably already know, the graph of x squared is a parabola. It's a nice little graph. For example, this is 1, 1, and this one here is negative 1, 1, and so on. Okay, so it's symmetric with respect to the y-axis. Questions about even functions? So if you're given a graph, it's kind of straightforward to detect symmetry. Just look at the picture and make sure that if it falls along the y, the two pieces overlap. If typically that's not the case, typically you're given a formula, so this box here is what you need to do. So you plug in negative x, and then you see what happens. Simplify and try to see if you can get back to the inner formula. If you do, then it's even. If you don't, it's not even. Okay? But in this case, we managed to simplify and get back to the inner formula, so f of negative x equals f of x. So it's even. Questions? Okay, so now let's talk about odd functions. So what do we mean by an odd function? So again, here we're only paying attention to two types of symmetries. The first one was symmetry with respect to the y-axis. That's the defining condition. X comma y is on the graph, and negative x comma y is on the graph. Now, odd function is symmetry with respect to the origin. So this is symmetry with respect to the origin. So remember, the origin is the point 0, 0. Okay? So basically, when you have your x comma y, to have symmetry with respect to the origin is the following. If you have a point, let's put it here, let's call this point x comma y, then symmetry with respect to this means that this is the mirror. The mirror is right here. So then this guy is going to reflect somewhere down here. So stuff in quadrant 1 reflects down to quadrant 3. Stuff in quadrant 2 will need to reflect down to quadrant 4. You understand this? Now your mirror is right here, this little dot. So how do we say that mathematically? Well, if x comma y is on the graph, then who is the guy that is directly across the same distance from the origin? That would be negative x comma negative y. So you need to change the sign for it. Okay? So if x comma y is on the graph, then it will always have a partner, and that partner would be negative x comma negative y. Do you understand this? So that's what it means to be odd. So that means f is odd. This is the definition. If whenever x comma y is on the graph, then negative x comma negative y is also on the graph. Okay? So that's what it means to be an odd function. Now, let's try to produce an algebraic way of telling this. So you can see that if via a picture, you can see if the function reflects from here to here, then you're good. And also you can, when you have a complicated picture, you can identify this in a two-step process. Remember, even means folding, and the two pieces overlapping. So what does it mean to be odd? We can do a folding business, but first you need to fold twice. So you fold, and then with respect to y, and then you fold with respect to x, and they have to overlap. So for example, if you fold with respect to y, let's say this point will come over here. Yes? But then when you fold with respect to x, the 2 points overlap. Do you understand this? Or the other way around. Fold with respect to x first, so this guy comes up here, for example, and then with respect to y, they will overlap. So it will be a two-step folding process. So when you have a picture, that's what you can do in your mind to identify. But what if you have formulas? Well, let's try to get something similar to the box that we have over here. So what are we saying here? The y corresponding to x, okay, is y, right? So the y corresponding to x is y. But then what are we saying here? That the y corresponding to negative x is negative y. But remember, y was the y of x. So this is the same thing as minus f of x. Do you understand this? So the y of negative x is the negative of the y of x. In other words, f is odd if the y of negative x equals minus the y of x. Do you understand this? So remember, this right here is minus f of x because y equals f of x. So this right here is minus f of x. Okay? But also is f of negative x because it's a y corresponding to this guy. Okay? So I will give you this equality. So this right here is what it means to be odd. So in other words, the good thing is that if you want to determine whether a function is even or odd, you always do the same thing. Notice that in both cases, we always plug in negative x into the function. So you plug in negative x, and then you observe what happens. If you do get back the original function, like in the x squared case, then we deduce, okay, it's even. Now, maybe you don't get back the original function, so you know it's not even. Then keep looking and see what is it that you get. If you manage to somehow factor out negative, and then you have minus the function, then you deduce, okay, it's odd. If that doesn't happen, then we say it's neither. Okay? It's not even, it's not odd. So we call it neither. Do you understand this? So what's a classical example for an odd function? What is it?
X is equal to y, or f of x is equal to y.
Okay, good. I had something else in mind, but good. So you can say f of x equal x, right? Not y, x, right? So that would be a classical example. Or also we usually use x cubed also as something a little bit nicer. So you can think of that one, or you can think of this one. All of these, they work, right? Because again, if you plug in negative x here, you're gonna have minus x, which is minus f of x. So that checks out. And over here, if you plug in negative x, you have negative x cubed. And now, because this is cubed, the negative survives. And x cubed is a function, so that's minus f of x. So all of those are examples of odd functions. For example, the graph here, as you know, is a line going through the origin. And this is certainly an odd function because, you know, if you do the two-step folding process, then this will go down here, and then when you overlap, when you fold again about the y, they will overlap. So certainly odd. And this one over here, picture is like this. Something like that. So once again, it's not even, but if you do the two-step folding, you will see that the pieces overlap. You fold this down, then you're going to get like a parabola upside down, and then you fold this two pieces will overlap. Okay? All right. Questions? Okay, so then let's do some examples. So determine symmetry. And remember, whenever I ask you for symmetry, we mean either even, odd, or maybe the answer is neither. Okay, but when we say neither, is that it's neither even nor odd. It could be other type of symmetry, like symmetry with respect to another line or something else. We're not talking about that. We are specifically talking about symmetry with respect to the y-axis, symmetry with respect to the origin, or none of the two. Okay, that's what neither means, none of those two. But you always do the same thing. Plug in negative x and then the term. So let's do. Okay. And for example, this is good to know when you're graphing a function, because if you have symmetry, then you only need to do half of the graph. The other half you get it for free by using symmetry. Okay? If you already know it's even, you only need to worry about what happens to the right of the x-axis, for example. The left part you get it for free by just reflecting. Okay? Same thing with odd and so on. So, it's helpful to be able to determine symmetry. Okay, so let's do this, and then we'll do a couple more. Let's see, let me do the first one. So again, if you want to determine symmetry of a function, you always do the same thing. You plug in negative x. It's just that depending on the outcome is what you decide to do. Notice that in both cases, we always do the same thing. Evaluate f at negative x. Evaluate f at negative x. Okay? So let's do that. So let's find f of negative x. So here you have to be careful. Use your parentheses. Then put the negative x inside. In this case, it happens that all the powers are even. So that's nice because that means that the negatives are gone. Right? The negative really doesn't matter because the even power kills the negative. And notice that this is exactly the same as the original function, right? So this equals f of x. So we obtain that f of negative x equals f of x. So what's the conclusion here? Can we deduce something? So f is even. Questions? Do you understand this? Okay. Let's see. Let's do 2, 3, and 4. This is an x cube down here. So what do you get for number 2? Even. Very good. So again, we just plug in negative x, and we see what happens. In this case, once again, the only x that shows up is a square, so that's gonna get rid of the negative. So we get the function. So even. Okay. All right. About number 3. Odd. Okay. Even. Okay. All right. So let's see. Again, what do? We plug in negative x, right? And we see what happens. So it will be 2 times negative x over negative x cubed plus negative x. Because literally every place that you see an x, put parentheses, and then filling inside the parentheses with whatever you're plugging in this case, negative x. So let's see, we have negative 2x. Now in the bottom, we have negative x cubed minus x. So apparently when you look at this, this doesn't look like the original function. The question is, can you make it look like the original function? Well, we could multiply top and bottom by -1, or we could factor out -1 down here to cancel this one, whichever you prefer. For example, I'm gonna multiply top and bottom by -1. Remember, you're free to do this, right? Here we're not changing, the actual value of the function, but when you do that, what do we get? You get 2x on top, and what do we get in the bottom? We get x cubed plus x. Yes? And it turns out that this guy here is exactly the same as the original function, right? So this equals f of x. So, sometimes it's not that obvious whether it would be even or not. So sometimes you may have to do some little tricks. Yes? So in this case, it turns out that f of negative x equals f of x. So what's the conclusion? It's even. So even. Do you understand this? Yes? Okay. So remember, don't be too quick in judging that it's not even. So just make sure that you cannot do anything to make the original formula pop up. Sometimes you cannot. And then you move on. You say it's not even, and then you try to check the other stuff. But make sure that you see everything. In this case, you see a bunch of negatives. You should wonder to yourself, well, I definitely can get rid of this negative when multiplying by -1. What will happen when I do that in the bottom? And then it turns out that they also disappear as well, and you get your function. Why do I want to get rid of this negative up here? Well, because I have a 2x. So I wanted to have a 2x also here, and then see what I end up with in the denominator. Okay? All right. For example, if this would have been a minus, that would be a different story, right? Because if this was a minus, then that means that this would be a plus down here, right? So when you do this business, you would have gotten 2x over x cubed minus 1. Actually, let's see, this would have been a plus, and actually it would be the same thing, right? It will still be.
If they're above the.
Maybe if I throw in then a square here, then that's when things becomes different. But that would be down there. Anyway, if this was a minus, it will also work. Okay? Because you go factor and then still it would do the job. Anyways, let's do number 4. Again, you always do the same thing. Okay? So plug in negative x and then just let it roll and see what happens. Just be careful when you plug in. Okay, so what happens here when we plug in? The negative survives in the first one, and the negative survives in the second. Now, this is not a fraction, so there's no trick that we can do here, okay? So either this is equal to our function or not. Is this the same as our function? So what can we deduce from here? No, we can deduce that it's not even. Remember, one step at a time. So what this is telling us so far is that definitely our function is not even, right? So this means this is not f of x. So you already know that it's not even. So because you know that it's not even, then the next natural question to ask is, okay, well, it's not even. Is it odd? What must be satisfied to be odd? What should this be equal to for us to deduce that it's odd?
Negative f of x.
Exactly. So then we know that it's not even. So now we're wondering, is this odd? Well, it would be odd if this happens to be negative f of x, because that's the definition of odd. Now you have two choices. Either you keep working, like in this case, it's easy enough that, because you want negative something, then the idea is to factor out negative, right? And then you see if that stuff that is left is your function. Or what I advise you to do, which I think is easier, is because you now are investigating whether it's odd or not, just on a different line, you compute yourself what this is. And then see if the two things match. Okay? If they match, then you're good. For example, what's minus f of x? That's minus this expression. So negative 1 times f of x. So that's negative 3x cubed minus 5x. And as you can see, these things are the same. Yes? So we do have that f of negative x equals minus f of x. So f of negative x equals minus f of x. And so what's the conclusion? So it is odd. Again, you can do it quickly, just right here, then the next step will be factor out negative, and then you will obtain this expression. And then you realize that this is the function, so it's really minus f of x. Okay? But my advice to you is, do a plug in negative x, you will get something. Once you're done simplifying as much as you can, look at it. If it's not your function, or if you cannot do any trick, then it's not even. The next question is it odd? Instead of playing with this more, because sometimes it will be more complicated, then just then go ahead and compute minus f of x, because after all, odd means these things should be the same. Okay? Compute this as much as you can. You will get something, and then you wonder, is it the same as this? If it is, it's odd. If it's not, if you get something different, then it's neither, it's not even, it's not odd, it will be neither. Do you understand the logical process? Okay, so we give you a couple more. How about let's do negative 2x cubed minus 5x. Okay, so here we have some functions. Let's determine the symmetry. Okay, so let's do it together because we only have like 10 minutes left. Okay, so for the first one, remember, regardless, you always do the same thing, plug in negative x. So I'm always try to shoot first for the even, and then if it's not, then you shoot for the other one, okay? It's a logical thing to do. Okay, so we plug in negative x. Now, in this case, notice that the negative will survive in both situations, right? Because we have odd powers. So the negative survives, but then there is another negative, so makes it a positive 2x cubed plus 5x. Yes? So, and that's it. There is nothing more that we can do here. So, question, is this the same as original function? No. So, what can we deduce from here? It's not even. Good. Now, the question is it odd? Well, let's see. How can you test whether it's odd or not? What should you do? Since we are now wondering whether it's odd or not, let's go to the next line and let's compute -1 times the function and see what we get, right? And then the question is, will they match? So if I multiply the function by -1, what do we get? What do we get if we multiply the function by -1? We get 2x cubed plus 5x. And they match. So what's the conclusion? So it's odd, right? So we get that f of -x equals minus f of x. So the function is odd. Do you understand this? Okay. About number 6. So we have neither number 6. Anybody else getting something different? We have odd over there. Anybody else? All right, let's see. What do we need to do? Plug in -x. So when we plug in -x, what do we get? -2x. And then here we have -x squared plus 1, but the negative is inside, so we have -2x over x squared plus 1. So the negative in the bottom is gone. Yes? So let's see. Is this the same as our function? So as it is, no. I mean, you could say, oh, wait, let's multiply to one bottom by -1, like the little trick that we did before. Yes, that would make a 2x in the top, but then that would make the bottom negative, and that's not happening here, right? So that trick is not really going to help us. So this definitely is not the same as our function, and there is no little trick that you can do for that, so it's not even. So the question is it odd? So what do we need to do to check whether it's odd or not? Just take our function and multiply by -1. That's the easier thing, okay? Well, here it's also easy because you can move. Remember, when you have a fraction, if one of the two, either the top or the bottom, is negative, you can put the minus in front of the fraction. It's the same thing. So, for example, -1/2 is the same thing as 1/-2 is the same thing as -1/2. You're free to put the minus of whatever you want, okay? And so in this case, you could put the minus in front, and then you end up with your function, right? So you get minus f of x. But if you don't see that, that's okay. Just compute minus f of x. Why? Well, because we already know it's not even, so we're trying to figure out if it's odd. So for to be odd, you need to compare these two quantities and see whether they are equal or not. So that's -1 times 2x/x² plus 1, and as you know, you multiply, you can think of that as -1/1, and then top with top, bottom with bottom. And then you see that they match, right? So they are the same. So it's odd. Do you understand this? So this function is symmetric with respect to the origin, right? So for example, we know that the point, if we put x equals 0, well, if we put x equal 1, then we're going to get 2/2, which is 1, right? So that means the point 1,1,1 is on the graph. What do you get for free now? What other point is on the graph as well? -1, -1, and so on. Okay. So every time that you have a point on the graph, now you get for free another. If we know it's odd, just reflect with respect to the origin. Okay. Change the sign for both x and y. Yes.
Why do you multiply the negative to the bottom?
Okay, because right. Okay, let me write it here. So this means -1 times this. So you can think of -1 as being -1/1 times this. So remember, the way you multiply fractions is, so this is really a number times a fraction, but every number you can think of it as a fraction by putting over 1. Yes? So -1 is -1/1. How do we multiply fractions? We do top with top and bottom with bottom.
So the -1 is on top.
So it's on top. I mean, if you can put it at the bottom, but then the top is positive, so it will be 2x over -x² minus 1. That's the same thing. But we really want to keep it in the top so that it matches our expression. Okay? Good. All right? Okay, let's see. Let's do this one quickly then. So for number 7, let's plug in -x. So what do we get? So we get -x³ minus 2 times -x over -x to the 5 plus 5 times -x. So in the top, the negative survives, so that's -x³, then plus 2x over -x to the 5 minus 5x. Yes? Does this look like our function? So it doesn't look like our function. Now, can we make it look like our function? So let's see. We notice at the bottom here that both of them are negative, right? So if I multiply the bottom by -1, I get my denominator. So let's do a trick of multiplying top and bottom by -1 and let's see what happens. And in fact, notice that every time that you see here, every single term has the opposite sign of what it should be. And we can fix that by multiplying top and bottom by -1. Multiplying by -1 changes the sign. So, and that will keep the same function. So if we multiply top and bottom by -1, we will obtain x³ minus 2x over x to the 5 plus 5x. And this happens to be the function. So what's the conclusion? What's the conclusion? So this is even. Okay. And how about the last one? Let's see. Let's do it quick. So we do the same thing, plug in a negative. So the negative survive here, so it will be negative 3x cubed. Now the other negative is gone because of the square. Minus 9. So let's see, is this the same as the original function? No, it's different, and there is no trick to multiplying by negative 1 top and bottom because there's no fraction here. Okay? So it's not even. Now, is this minus a function? Well, let's see. Let's check. And you can visually inspect that. Let me just write it down. So if we multiply the original function by negative 1, what do we get? Negative 3x cubed minus 2x squared plus 9. And these two things are different. Okay? So not the same. So it's not even, it's not odd. So this one is neat. Okay?